There we go. Okay, that's it.
So good. Super good.
Three things you want?
A chord. So I want a circle. I want you to draw a chord, a diameter, and a radius. Those are the three things I want you to do. On one circle, yeah.
You turn the arrow?
What?
To the top?
Oh, do you want me to turn the 8?
No problem. Okay. And then a line?
Oh, I feel great. We got this cool massage chair at our.
I know, I saw you go in there.
I mean, like, even though they had lunch, I'm like, I had to go get my massage first.
You were getting massage, not?
Well, like last 15 minutes, I ran over and ate as much as I could.
Well, that's the radius at the beginning.
All right, so let me give you the. Actually, if you had to describe the radius, how would you describe the radius right now? Halfway to the center. You said the center, right? Okay, so the thing with the radius is it starts from the center and ends up on the circle, okay? A chord is a line that technically has endpoints on the circle, okay? So, Alina, actually, why don't you erase your last segment that you just drew? By definition, does Alina have all three lines, if you think about it? She actually does. Why is that? She has a radius, and then she also has a diameter, but why does she also have the chord as well? Same with Zane. Zane's in the same, and I'm so sorry, and David as well. Why is the diameter a chord as well? It goes from one end on the circle to the other end. So stay up there. Hold on, I have another exercise. Okay. Now I want you to draw two chords on a circle, right? Both those chords meet at a singular vertex. What the heck does that mean? Try to draw that scenario. If you're successful, you might have a V in your circle. That's what you should end up having. Yes, that's actually really good. Yep, you can do that. All right, and then go ahead and have a seat, and then we can bask in the glory of our beautiful, beautiful drawings. All right, let's go ahead and start taking some notes here. If you may. Okay, so 11-4 inscribed angles. Everyone there has successfully drawn exactly what I wanted you guys to draw, okay? But now we're going to talk about that a little bit about what you just drew. It is?
Yes.
Oh, sorry. Oh, hold on. The reason why is because of this here. And Zane, can you get the lights maybe? Because this isn't working out as well as I thought, the lighting. And you guys got plans for the upcoming summer? It's coming up very soon. Yeah. Shamaria, what do you have planned? Huh? Dance. All right, there we go. Yeah. That's pretty much, I'm not professional like you, but all I plan to do is just surf. That's it. Just surf. Okay, so let's draw what we just drew. Okay, sorry, mine's a little bit ugly, right? It says A, B, and C, okay? What you just drew is what's called an inscribed angle. An inscribed angle, right? By the way, last week we went through 11-1 and 11-2. We did not go through 11-3. I just put up a video for 11-4 or 11-3 last week. So please make sure you go to my website and check out any videos that you still have any problems with. So if you need to write this down, the stuff I did not go in class, 10-4, 11-3, but there are videos on my website. So if you've been coming to my classes, okay, make sure that you log on to the website and check it out. I've had the videos, or I have videos for every section so far. Also, one more thing, if this this little notification on the bottom right here in the screen ever goes away, please tell me and I will give you an extra credit point, okay? And just to let you know, the extra credit points really do help to boost your grade. Like, it goes up by like 0.2 to 0.3%. Like, so that's a lot, you know? So what I'm saying is, yeah, just let me know if this ever goes away, because that means it's not recording anymore, and that kind of stinks. Okay, so inscribed angle is basically two chords on the same circle that meet at one vertex. If you don't know what that means, this is the vertex. Vertex is where they meet, okay? So that's the vertex right there. And there's something beautiful about these things. It's a very easy rule to remember. We may have not gone over this last time, but does anybody remember? So this is the inscribed angle, okay? That's in black. What about what's in green from B to C? Does anybody remember or recall what that is called? That piece of the circle, just on the outside of the circle. It starts with an A. Might have been in your reading, and I don't think that we went over together over. What is in green is called an arc. Okay, I color code it to make sure that you understand that that's an arc. So here's the deal. The measure of angle BAC, please remember that A, the center, is pretty much where like the angle starts. Like BA right here, that's the main angle. C, B to A to C, or CAB, okay, is equal to only half of the size of the arc, BC. Okay, so what that means is this angle in here. So let's say if I said, let's say if the arc was, someone give me a number for the arc. Any number between 1 and 180. 4? How about a lot? A little bit higher. Not a lot higher. A little bit higher. 80. Why not? Okay, that's good. 80 works. Okay, so by this theory, if this arc is 80 degrees, okay? Actually, how about an arc that goes over the whole circle? How much is that? How many degrees is that? 360. Get it? 360. But only this chunk is 80 degrees. How big is this angle inside, the inscribed angle, going to be? Yes. How did you find that out? What's that? It's half of 80. So again, the inscribed angle is always half of your arc. Does that make sense? Yeah, it's not too bad, right? It's not too hard. So I'm going to go over another point here on the bottom, and then we're going to go basically over some examples. Use inscribed angles to find measures. Sorry if you guys can't see that. Let me kind of lower this down a little bit to find measures. Okay, and then I'm going to draw a circle here. I'm terrible at drawing circles, by the way. I can't do it, right? They don't make sense to me. But I'm going to try my best. We're going to do a chord from here to here. That's going to be PM, all right? And then I'm going to draw another chord that comes from the vertex of P all the way down to N. Boom. N. And then this is going to extend to another chord out here to O. So you should have what looks like a Z, or maybe like a falling N that's falling forward on its face, you know? And then let me give you some numbers. The arc here, I'm going to draw this in green. The arc MN is 70 degrees. The inscribed angle is 56 degrees. I want you to solve for two things. Please find the measure of angle P, and please tell me what the measure of the PO, the arc, is going to be. Okay? So go ahead and work on the whiteboard if you want. Please don't redraw this, but please give me number 1 and 2 on the whiteboard, please, right now, okay? Just give me quick math if you can. If you don't know, just ask a neighbor really quick. What the heck is going on? Okay, I don't know. Tell me if it gets too cold, right? Cool. Good, sir. Good job. Good job. Now go around and help anybody that might need help. So Obide's going to come around, check your work. If you need help, ask Obide, okay? Sick. Great job. Awesome. Lena's got it now. Sick. Just letting you know again, arcs are twice as big as the inscribed angles, okay? So what is the measure of angle P? Just this guy right here. What's his measure? If the arc is 70, then what should this be then? Should be half, right? Should be half as big. So you could do this. You could say half of the arc MN, the arc of MN, or I'll color code that. Sorry, I got to keep consistent. MN, the arc MN. And if you think about it, half of that, half of 70 degrees is equal to the final answer of 35. 35 degrees. So that's our final answer for measure of angle P. And then the arc PO is going to be 2 times as big as which angle? What is the angle that's twice as big as? Yeah, it's 56, otherwise known as angle N, which is 2 times 56 degrees. Not bad. That is 112 degrees. Not bad at all. Okay. Now, as an activity, you can do this on your paper now. Please listen to my instructions, okay? So here's the theorem. Draw me a circle. Go ahead and draw me a circle. I'm not going to do it first. You do it first. I don't do it. You do it, all right?
Like the same size.
However you want, yeah. Not huge, yeah. Good question. It's not huge, just like a small size circle. And then draw me one inscribed angle. Draw me an inscribed angle. Yeah, kind of like what you had before. You drew a V. Draw me some kind of V. It doesn't have to be a perfect V, just anywhere on that circle. So I chose to do it here. I don't really care. Anywhere is fine, okay? There's my inscribed angle, right? Okay, so you can, yeah, we'll just keep it that way, okay? Then, if you have a different colored pen or whatever, you can use that. You don't have to. But from these 2 points, draw me another inscribed angle. So from these 2 points, draw me an inscribed angle that also meets at these 2 points somewhere else. Try to do that. If you don't like it, you want to follow what I'm doing, you can go ahead and do what I'm doing. You can follow ahead. So I chose to do mine right here. They meet at the same 2 points here. So I'm going to name one of my inscribed angles angle just 1. I'll just say that this is angle 1. This is angle 1. And the other one is inscribed angle 2. So crap. So I want you to take a look. If you drew a decent circle, right? Not like mine, okay? Let's say that, so on your arc, draw it in a different color or like highlight it in a different color. If you have a different color, if you don't, it's okay. You can just like kind of like make this part darker here. The arc, we'll say, is from D to A. Their arcs are the same. So first, let's do a few things here. Let's say that I have 2 inscribed angles. They're angle 1 and angle 2. Or angle 2, okay? The only arc that they have, what is the arc going to be called? What is the name of the arc? How would I write that? Yeah.
DA with the
Little squiggle on the top? Yeah, not bad. Okay. So we asked for when he was color coordinating things. Boom. Okay. That's arc DA. So we're going to say this. If 2 inscribed angles, which you just drew, 2 inscribed angles, it's called intercepting. So it sounds kind of weird, but they intercept the same arc, meaning they kind of share the same arc. What do you notice about your angles? I know mine aren't perfect, but you can look at this one. This one turned out a little bit better. This is what I did the previous class. These are the inscribed angles here and here, right? What do you guys notice about the measure of those 2 inscribed angles? Roughly. They could be equal. They are equal. Okay? Hopefully look on your circle. If you drew it successfully, these 2 arcs should roughly look about or these 2 angles in here, these inscribed angles, should be about the same. So then their angles are congruent. So in this case here, what I'm going to say is measure of angle 1 is equal to or congruent to the measure of angle 2. It's a pretty nice, simple theorem. It's not too bad. For me, this is probably the stuff that I like. It's a little bit intuitive. It's not too hard. Okay, so we're going to go ahead and go on to a problem now. Okay. I like these notes pretty good. So let's do an example up here. Can you guys see this? Okay. Here's the example. Let's draw giant circle. Again, I don't like drawing circles. I just stink at them. Let's do 2 points here, and then we're going to call this an arc. That's arc SV, okay? This is an arc. Draw an arc SV, right? And then draw me a chord here. Then draw me a chord here. Or inscribed angle, I'm sorry. That's what I meant to say. Inscribed angle. And then we say that this is 3x minus 5 degrees, all right? And then up here, it's going to be 2x plus 15 degrees. And that's T and U. First off, what can we say about angle T and angle U? What can we say about those 2 angles? Why are they the same? Yeah, what is the theorem we just talked about? What are they sharing the same? What thing are they both sharing? These two they're sharing arc SV. If you share the same arc, your inscribed angles will be exactly the same, no matter how I draw it. If you don't believe me, try to draw a perfect circle, and then just draw another arc out here, and then draw two inscribed angles anywhere you want. Their angles should be roughly the same. Okay. In fact, I drew Spider-Man, right? Spider-Man. Okay. Spider-Man, right? I'm just kidding. Okay, sorry about that. Not important. Knowing that, can you solve for the measure of angle T? I'm going to give you guys like 5 or 10 minutes to do this. If you come up with the correct answer, I will award you an extra credit point. Okay? Solve for angle T. How big is angle T? Please do this on the whiteboard, though. Don't do this on your paper. Get up on the whiteboards. Get up. Get up. Get up. Get up. Get up on the whiteboards and get to work. Please help each other out, though, too. This is not like, this could be a scenario where everyone gets extra credit points if you understand how to do it. Boom. Okay. Huh? X is, but is the, I'm asking for the T. That's correct. Okay, so I do know that T is congruent to U. Whatever. Go help out. Please walk around and help out. Okay, Shamara, lean into, huh? So if you guys need help, you can ask Zane. Okay, Zane can help you out too. Oh, my back. Very good. Okay, so Zane Obaid has the same answer, so you're good. So let me give you guys some extra credit. See where's my extra credit sheets. Okay, Zane, Obaid, Alina. Looks like you guys got all points. Zanyo, Obaid, Alina, Tanon, Sienna looks like Shamaria. Nice. That looks like an everybody thing. All right, cool. Everybody got it then. 1 extra point for everybody. 1. Each one is worth.
So 6 people got it, so we just get 6 points.
No, that's not how it works. Good theory. That's not how it works. Okay. Okay, I like that. It's a collective thing. Okay, so what we'll do here is we'll set up that measure of angle T is congruent to U. Where did I just do my pen? Back. Okay. Or my neck, actually. Okay. So we're going to set up 3x minus 5 is equal to 2x plus 15. You should recognize that we're looking for a variable that makes these sides equal, which is x. So we just subtract 2x from both sides, which give us x minus 5 is equal to 15. Then we add 5 to both sides. You guys were very good. You guys got x equals 20, and you guys were awesome in that you didn't stop there because that's not what I was asking for. I was asking for how big angle T is. So at that point, all you have to do is you just got to plug back in. The measure of angle T is 3x minus 5. You just plug in that x value. 3 times 20 minus 5, that should be 55. This would be 60 minus 5. Kind of a trick question here. What is the, without doing any math, what is the measure of angle U? What would it be? Why would it be 55 again? The whole, what's up? I heard you say some. Okay. Oh, okay. All right. Well, I think what you said was they're the same. Okay. They share the same arc and they're the same. So that's why it's a trick question. But if you did plug it in, 2 times 20 plus 15, if you did the math right, that's 40 plus 15. Oh, you don't have to do this, by the way. You don't have to do this. That's 55. That's not a coincidence. We literally found a value that makes both sides equal. That's what we wanted. Okay. So there you go. Right? Very, very good. Let's go through one more theorem, I think. I think this is the last theorem for this section here. So that was a good example problem for you. This is theorem 11.8. We're going to draw me a diameter in the circle. F to H and dot the line. If I said that's the diameter, how big do you think the arc is going to be, FH? How big do you think FH, the arc, is going to be equal to? If I said it's half the diameter, or half the circle. Half of 360. The whole thing is 360, so half of that. So again, FH is the diameter, That means the arc of FH is 180 degrees. Not bad, right? Then, what if I drew an inscribed angle? Okay, so I'm going to go from here. I'm going to avoid giving you just like making this angle 1. I'm going to make this a little bit more complicated by saying the measure of angle F to G to H. I want you to get used to drawing it that way or writing it that way. How big do you think FGH is going to be? Go back to your first theorem. If your arc is a size, how big is the inscribed angle in comparison to that arc? It's going to be half of whatever your arc was, which is 90 degrees. That is a right angle, right? So there is a theorem about this. I can draw, if I don't draw this next part. If I drew another angle here, guess what? That will be another 90-degree angle, because as long as you have an arc that is half of the circle, your inscribed angle is going to be half of that, which is 90 degrees. That's a theorem. So let's say if the angle FGH intercepts FH, which is if FH, the segment, this line segment F to H, is the diameter, then the measure of angle FGH is a right angle, 90 degrees. Then you can also say, what about the triangle? Let's look at F to G to H as a triangle. FGH, and then I draw in that line. Does everybody see that triangle there that I just drew? F, G, and H. Do you guys see that triangle now? What kind of triangle is that? It's a right triangle. FGH is a right triangle because it has 180, or it has a 90-degree angle. So I say these three lines, these three dots, I'm going to say, therefore, FGH is a right triangle. Okay? Guys, ready for an example problem? Oh, yeah. Okay. Oh, yeah. Okay. All right, so let me see. What would be a good one? Okay, I think I got one. Sorry, give me 1 second here. Where's the one I wanted to show you? I guess I don't have it here. Okay, I guess not. Okay, so here's an example here. I really think I should get like some kind of circular thing so I can just make perfect circles. That's really bothering me. I can't draw a circle. Oh, thank you, whoever brought this for me. Who knows?
That's the cap.
Don't trivialize this. This is very important to me. Still not a perfect circle. It will never be perfect. This is a sign. Okay? Whatever. What can I do? Okay, draw me a diameter. draw me a diameter F to H, and then to G. And then we're going to say the center is J. Sorry, like the center of that circle is J. So what I'm going to say is this. This is your example. And the only thing that's given to you is FH, the line segment to F to H, is the diameter. So just to kind of get you used to seeing this in the book of circle, and there's a dot J. That just means that circle has a middle point called J. So that circle, a dot, and J means that this circle belongs to that center J. It doesn't really belong to it, but I'm just saying this circle has a center of J, okay? Here are some things that you might need to know. This angle in this corner is 9x minus 3. And in this corner, right, is going to be 4x plus 2. I'm not going to ask you what x is necessarily. That's part of finding this thing. But be very, very careful. It's not what you think. Don't set these up equal to each other because that's not the case here. Right? That's not going to help you out. But I want you to find the measure of angle F. So you do need to find out what x is, but you can't set them up equal to each other. That's not the theorem here. Any suggestions for what we can do so far? What about, do we know? Okay, so I don't know 4x plus 2 and 9x minus 3. What do you got, David?
You can set 4x plus 2 equal to.
Wait. Go back. Why 180? It's cut in half. Okay, so hold on. So let's back up a second. Let's look at a few things here. I know that F to H, that arc is 180 degrees, right? Because it's half the circle. What else do we know so far on that? All right, this other half is 180. Okay, fair enough. All right, what else do we know? G is 90 degrees because opposite of 180 is an inscribed angle. And the rule is your inscribed angle is always half of that. So that's not bad. That's 90 degrees. Okay, we got that. What else can we do to solve for this thing? What about triangles? Anything we know about triangles and the angles? Not necessarily. Just, huh? Wait a minute. What all adds up to 180, Obaid? The angle's in the triangle, right? So what you're telling me is the angle F. If I have the angle F plus the angle H, and what else? The angle G, I should get 180 degrees. That's not bad. What can we do next if I wrote that? That's true. What can I do now? What? You're just mocking my writing now at this point, okay, Zane? So, right? Do you want to pass or not? I'm just kidding. Okay, I'm just kidding. I do have a huge difficulty with drawing G's. I can't draw. Apparently, I don't know how to draw a Q because this is how I draw my Q's, and people are telling me that's a G. So, all roads to Mr. Wee's problems lead to the fact that he can't draw a G. Okay, that's fine, fairly fine. But I digress. Let's go back to our point here. This is 4x plus 2, right? H is 9x minus 3. What do we know about angle G again? How much is that equal to? 90 degrees. That looks like it's set up for success. Because all I have to do now is combine everything together, meaning 4x and 9x can combine because they're like terms. That 2 and negative 3 will add together to get minus 1 plus 90. So I'm not finished yet. I could add minus 1 to 90, giving me 13x plus 89 is equal to 180. I could subtract 89 from both sides. Let's do some quick math. What is 180 minus 89? Yeah, I believe you're right. Yes. Then you divide both sides by 13, and then ultimately, what should your x value be? If you don't know, should it be, my sir? Right? I mean, guys like this? Oops. Maybe you don't. Oh, there we go. It's fancy, huh? This is so funny. This is what's called an emulator. Like, meaning it takes a real piece of hardware in real life, and then it copies how it functions exactly. Okay? So the thing is, it emulates it so well, I literally can't do anything until I press the on button on a computer program. That's weird, right? Have you ever used Facebook and had to press on Facebook? That's irrelevant. Have you ever used Instagram and you turn on Instagram? Facebook's pretty old now. Does anybody still have a Facebook here? Yeah? I'm glad. Oh, maybe more for professional reasons or no? Yeah? Is that why? Okay. Yeah. You have Facebook? Okay. Because we're old souls, right? We still have Facebook. Okay. Okay. So let's see. 91 divided by 13. Let's double check here. 7. Okay. And are we done?
No.
What did the question ask for?
Angles. But no, didn't actually have a question.
It did. Well, it was a command. It wasn't really a
Measure of angle F.
measure of angle F, which is so technically the measure of angle F is equal to 4x plus 2, which is 4 times our x value, which we'll plug in as 7 plus 2. That will give us 28 plus 2, which will give us 30. Your final answer should be 30. The measure of angle F is equal to 30.
Does that emulator have a graph?
Oh, I'm not really sure why. I think the developer like rabbits or something. I'm not sure. I don't know. If it's a euphemism for something, I don't know, and I really don't want to know. So we'll just leave it at that. Okay. All right. Everybody get to the whiteboard now. We're done with 11-4. We have one more section today, and then 11-6. Mr. Wee really thought ahead of this one. He already made a video for 11-6 last week. Okay, so that's finished. But now we're making this video for 11-4 and 11-5, and then officially we should have every single video for every section you need on my website. Okay, so over the weekend, you want to study for your exam, just read that, and then month 10 we'll have a final. I believe it'll be take home. Okay, as far as I remember in my memory, it's take home, and then your homework basically for that month is nothing really new, no new homework assignments, but your homework for that month will be to take notes on some sections. Notes, but no questions, okay? No problems. So that'll be the final exam, right? So this is your final traditional exam. Next month will be your final exam, but that'll be like a cumulative final. But
It's still worth it.
it's still worth about the same. So it's like another month test, basically. But it just happens to be month 10 is like a recap on everything you've done, but it'll be a take home, okay? Because I think it's just too long it's long, okay? So it's got like 10, 20 questions, I think. So I know. So Mr. Wee's still evil, okay? He's not quite nice, right? So you're gonna have to take that home and finish it, but it'll be a take home, okay? So this is why I really consider this to be like the last class to me. It's like the last traditional class, and then that's it. Right? So we're almost done. Okay. All right. So get on the board now. Please, everyone's rushing. Don't rush to the board. Okay. Please get to the board. Okay. Draw me a circle. And then draw me a line that hits 2 points on the circle. A line that goes by, it hits the circle at 2 points. I don't think you'll have a problem with that one. Draw me a circle that has a line. That's hitting 3 points on the circle. I want a singular line. That was good. That was a good example of what not to do. That was kind of mean to say it like that. That's a good example of something that is not necessarily correct. Okay. Yep, and make it go past that too, Shamara. Like outside the boundaries of the circle. Okay, good. You drew what is called a secant line, okay? Now, hold on. Draw me a line that now touches the circle at exactly 1 point. One and only 1 point. A line, when I say line, I mean a never-ending line. It cannot stop at the circle. It must keep going. So, yeah. Nope. So, yours sadly stops at this. How do you draw a line? Nope, that stops at the circle. Oh, Sienna. Sienna. Nope. That stops at the circle. I need a line that goes on and on forever. Huh? That's good. That touches 2 points on the circle. That's what I wanted you to do the first one. Give me a line that only hits the circle at 1. Nope. It has to keep going on and on forever. Not stop.
I know.
Nope. Again, that stops right at the circle. It needs to go through the circle, or it needs to bypass the circle. Okay, it looks like we got one group that got it down. Well, I'm sorry, your head and your hairs. Okay, we have 2 groups that officially, we have 3 groups. We have 4 groups now that officially have this, okay? Okay, very good. All right, let's have a seat. You guys did very well, okay? All right. Okay, here are your notes. 11-5 tangents. Okay. So, here is a secant line. You just drew what is called a secant line. It is a line that intersects. When I say line, I mean not a line segment, okay? Just to kind of let you know, a line versus a line segment. There is a difference. A line segment has confused. Okay. Just to let you know, you don't have to draw this. You can draw this on the side maybe as a side note. A line segment is like 2 points and it stops. Let's say that's A and B. And how you would write that is what we're used to doing. A, B like that, okay? A line would be like this. It crosses 2 points, but it does not stop. So between 2 points, and how you would write that would be A, B with arrows at the ends. There is a difference. So when I say line, I just mean something that goes on and on forever, okay? And when I say line segment, it just stops at 2 points, the end points, okay? So here, what I'm saying is this is a secant line. This is a secant line, okay? This is a secant line, and that is a line that intersects. So I didn't say line segment. I said line that intersects a circle at only 2 points. Any 2 points, though, but only 2 points. A tangent line, not a targent, okay? It looks weird, but it's a T-A-N-G-E-N-T, tangent line, is any line that hits the circle at exactly 1 point. I know I didn't draw it perfectly, but let's imagine that I did, and it passed this circle at 1 point. That is what's called a tangent line. Yes?
So is technically a chord also secant line?
It's a secant line segment. It's not a secant line. Again, a line goes on and on forever. But yes, you can say a chord is a secant line segment in that it touches the circle at 2 points but does not continue on and on forever. So his question was, okay, so again, I'm going to draw this maybe in pink so you know that you don't draw this part here. Or actually, whatever is drawn in yellow, you don't draw, okay? So let's do that for now. A chord is anything with any line segment in a circle that touches this circle at 2 points. That is also a secant, not a line, but a line segment. Okay, secant line segment, meaning it does go through, intersects the circle at 2 points, but the only difference is it does not go on forever. A secant line segment is something that just stops at 2 points. Okay, so I digress. You don't have to write that down. Now we're going to do a theorem. And draw the circle first on your paper. So you draw the circle. Attempt to draw one again. I'm just not good at this.
Use the other side because that's bumpy.
No, the other side is bumpy, like bumpier. Hard to believe because the way I draw it makes it look like the side I chose is the bumpy one, but it's not. So I have a lumpy circle. Now draw a tangent line. Any line that is tangent to the circle. Does not matter. Draw a line that is tangent to the circle. I'm not going to do it first. You do it first because I want everyone to have something a little bit different. I will choose mine to do right here. You don't have to copy me. I just chose, and let's see. Mr. Reed's getting a little fancy. Now he's going to use a ruler, I guess. You know? I guess a ruler. No, a protractor. He's going to get super fancy. Okay. Okay. The reason why is because I am the teacher that you're modeling yourself after in terms of the content, not necessarily in behavior or anything. Okay, I'm not saying that. I'm just saying in terms of the content. Okay, so that means my notes have to look a little bit nicer. Let's draw a point that is exactly in the center of the circle. Okay, now what I want you to do is whatever point that it touched at, I want you to make a straight line to that point that the line, that your tangent line is at. Okay, everyone should be a little bit different. But can you tell me anything about how this angle measure is right here? Everyone please look at your model that you drew. In fact, you can look at each other's. Even though you drew different lines of tangency, what degree or how many degrees does that roughly look like? 90 degrees. That's not a coincidence, folks, okay? I wanted you all to do different ones. If you look at each other's, as long as your circle is, without judging each other's circles, okay? As long as your circles are pretty good and not too rough, you should have ended up with a 90-degree angle. So, by the way, this is what's called a point of tangency. That means where does the tangent line hit? It's the point of tangency, to be fancy. Point of tangency. And then basically this theory says this. A tangent line to a circle is tangent, meaning this line can only be tangent if and only if, so please underline that. That is a big thing to say. If and only if. In your book, it might even say IFF. That means if and only if the line is perpendicular to the radius. All right, very nice. To the radius drawn to the point of tangency. So this looks like a lot of words, but really this is the radius I'm talking about. If you drew a radius that hits the point of tangency, you will make a 90-degree angle. It does not matter where your tangent line is. If you make a radius from the center to the point of tangency on your circle, you should still get roughly 90 degrees, okay? So again, your line basically, that judges your line. Did you make a good tangent line? If your tangent line did not actually hit, so don't draw this. I'm going to draw this in yellow. If your tangent line, you're telling me that this is a tangent line, and it totally isn't, okay? It's like hitting at 2 points. Okay, if I suppose my tangent line's like here, actually that looked pretty good. Still drew a pretty decent one. This looks like it's a little bit bigger than 90 degrees, okay? So I guess that wasn't a great example. Or maybe here to here. This is definitely not a tangent line at all, right? But let's just say that I think this point is like the point that I don't know, that is tangent or something. I don't know. Oh shoot, it's a little bit bigger than 90 degrees. Okay, I'm not proving my point well. Okay, I give up. Right? Please just take my word for it at this point. I'm not doing a great job here. Just great content right there. Okay, we're gonna move on to a example here. Ooh, challenge. I see only challenge in this, which I think you guys are ready for. Okay. Identify a tangent. Now you got to check to see if this line is actually tangent or not. I mean, obviously, my struggle in trying to draw this, you can kind of tell that I am trying to make this a good tangent. So draw a circle. If you see this black cap, that is indicative that you got to draw a circle. You know, Mr. Wee's struggling to make one. Okay. Draw a suspicious looking line that looks like it's the tangent line, but you don't know for sure if it is or isn't. Okay, and then let's draw the center of the circle, I guess. So I propose that this is the point of tangency. Let's do that there, right? And we'll say it meets out here at K. So that's K. That's a point K. This is L. This is J, right? Let's dot that, right? Say it meets at M. This is 9. 8, 15. So draw all that if you can. So what do you guys think? Does KL look like a point of tangency? Or not a point, a line, a tangent line. Does KL look like it's tangent to this circle? Yeah, it kind of does, right? But we don't know. So here's a few more things that are given to you. We do have to say that JL is a radius of circle J. Then we also know that K to M is 9, by the way. Sorry, I have to make that very clear. That 9 does not belong to this whole thing. It only belongs to K to M. This distance we do not know. We do not know this distance at all. We don't know M to J. Your task will be to determine, or our task, we'll work together first, determine whether KL is tangent to circle J. Is it actually tangent or not? That's the question. So I remember something about a tangent line and touching the circle and making 90 degrees. Where on this guy should be 90 degrees? L.
JL.
What'd you say? JL. So that's just the line. You're telling me that this line is 180 degrees or 90 degrees, or what is it? What is JL? If you said JL, I just think of the line. Oh, JK is a line. So how about J to L to one more point? So I know you're talking about an angle. J to L to what? To K. JLK. JLK is 90 degrees. So anything in purple. So I'm going to make this rule. So don't worry. That doesn't mean you have to color code it the same way I do. I'm just going to say anything in purple is a solution thing. Okay. Or things that are going to help me to get the solution. So I know that angle JLK is equal to 90 degrees. I got that. Okay. What else can help us with this, solving this problem? Or actually, do we know if it's 90 degrees? For sure? Well, actually, we don't. I just said it looked like 90 degrees, right? Sorry. So I kind of muddled my point here. Is this actually 90 degrees? Well, we don't know, but what we could say is there's a way to prove that, okay? You guys see that triangle there, right? There is a triangle there. It looks pretty obvious, right? That I want to draw a triangle. If I can prove this is a right triangle, I have successfully proven that this angle is 90 degrees. And if I prove that that's 90 degrees, I have proven that KL is tangent, okay? But the question is, how do you prove this is a right triangle? I don't know. So, okay, so first, let me make my point. You don't have to draw, you don't have to do all these things on your homework, but this is just notes to do your homework, okay? Notes that will help you to do your homework, but you don't have to do what I'm doing here. So we have to prove that the triangle JLK is a right triangle. If I can do this, I can prove that that angle is 90 degrees, and I have proven that KL is tangent, okay? So how we do that is the Pythagorean theorem. A squared plus B squared equals C squared. So don't look at the numbers. Just look at the triangle here. Where is the hypotenuse, the longest side in this triangle? What line is it?
JK.
Yeah, it's J to K, right? So that means that j to k should be my c squared. Ugh, crud. I don't know how long j to k is. I only know how long km is, right? I know how long kl is. I know how jl is. But how do I know what mj is? Any suggestions here? What do you think, Zane?
You could just use the Pythagorean theorem and do 8 squared plus 15 squared equals 9 plus x parentheses
You could,
squared.
but there's a much easier way. Much, much easier. What do you think? Let me see if you can connect the dots here, right? Get a dry erase marker here.
Is KM 1/3 KJ?
K, I'm sorry, what'd you say?
Is KJ? K to M 1/2, 1/3 K to J.
Oh, or M to J, you mean? Or what did you say? So KM or KL, I'm sorry, KM.
KM.
Uh-huh.
Is that 1/3 of the whole?
It looks like it, huh? But there's what theory can lead us to doing that? You know what I mean? You got to use a theory to prove that. But no, it's not. But it could just be for. It looks like it is right now. But again, don't ever trust my drawings, okay? Because obviously you can tell I can't even draw circles. So don't trust the way Mr. Reed draws. Let's help out each other here. This is a diameter, so that means it has to go to the center, okay? And let's say that's 9. Whole thing is 9 feet long, right? What about this diameter? How long is that going to be? It's also going to be 9. Doesn't matter, okay? How about this? What if I took you one further? A radius from here to here is 4 feet. What about this radius? Even if I drew it ugly, what is the radius supposed to be here?
So it's going to be 4.
It'll also be 4. Do you see 2 radii on this circle that should be also 8?
JM.
JM, by definition, maybe you don't see it, but let me point it out to you. Here is a radius, that is 8. Any other radius on the circle, as long as it comes from the center and your circle is drawn nicely, not sloppily like Mr. Wee's, okay, if you drew another radius from here to here, that would be 8. If you don't see it, J to M is also another radius, making that 8 as well. 8. So that means that MJ is 8, and then if we knew that JK is equal to KM plus MJ, KM would be 9 and MJ is 8. So now we know that whole side is 17. Again, on the homework, you don't necessarily need to show me this, okay? That would really help if you did, right? But all you really need to know is this last point. A squared plus B squared equals C squared. A squared, okay, we'll just say that A is like J to L, which is 8 squared, plus KL, which is 15 squared, is equal to what squared? 17, because that's the length of this whole guy. 17 squared. This is really the takeaway from this. And as long as this is true, we have proven that we have a right triangle, which proves this 90-degree angle, which proves that this is tangent, okay? So let's check. So I got 64 plus, what's 15 squared?
225, I think.
It is.
Yeah.
And let's say you don't know what 17 squared is. I'm just finding an excuse to use this really cool calculator. I really like it.
That's right.
Whoops. It's 289.
Is that free? But technically, was it free?
Well, just we had to do some tricks to get it. So
That's dope.
60.
Yes or no?
Well, I didn't have to pay for it,
Just that you did.
but I'm just gonna leave it at that. Okay. But ... That's it. Okay. But ... Right? Okay. So, is this true?
Yes.
Yes. So that means this is a right triangle. So what this proves to us is because if this proves the Pythagorean theorem, you have proven that the triangle JLK is a right triangle, and then you've also proven that KL is a tangent line. Okay? Let's try that now, because there's a lot of notes here. I want you to actually try a problem where, let's see, how much time we got? We got like 10 more minutes. Okay. Fair enough. I want you to try a problem in the book. Let's see. Try this one. Prove to me that GH is tangent to the line, or tangent to the circle. Dang it. Okay. Freeze frame that. Okay. Please try and prove to me if that's a right triangle or not. Or, yeah, if that line is tangent. Please prove to me if this line is tangent to the circle. Please do this on the whiteboard. If you don't know, look at each other's work. Figure it out. Ask each other too. Don't just copy it, but ask them, what does this mean? How did you get this? How did you get that? I'm going to come around and help. H to F is not 12. So I'm going to pick on you, Alina. Oh, you erased it. You're too quick. Okay. So, all right, let's just say that I made a mistake and I said this was equal to 12 squared. This is 12, not H to F. How long should HF be? So let me help you out. Let's look at Zane's. This is 6. If here to here is 6 and that's the radius, how long should this to this be? That should also be 6. So what do you have to do to find H of F now if you know that this is 6? This is 12 and then this is 6. What do you do with those two numbers? You just add them. So it's 12 plus 6 and then that's 18. There we go. So Alina's got it down. That's what you want right there. So I'm going to copy you guys now, right? So let's see, I got H to F is actually 12 plus 6. This is 6, this is 6. It's 18. So that means you have to do 8 squared plus 6 squared is equal to 18 squared. Ooh, very good. Okay, so 8 squared is 64 plus 6 times 6 squared is 36. And 18 squared, we don't know what that is. What is 18 squared? Oh, is it really big? Yikes! Is that equal to 100? Whoops, did I jump ahead? Okay, so that's, what is it? That's 324. 64 plus 36 is 100. Is this equal to 324? No. So no. Not a right triangle. Not a right triangle. So that also means, is HG tangent to the circle? So let me say this. If you cannot prove that this is a right triangle, this is not 90 degrees. Tangent lines make 90 degrees with the radius. That is not 90 degrees. So we will say HG is not tangent. All right, guys, that is the end of class. I have one more problem, but I think I'll just tape it really quick, and I'll put this video up. And that's it. You guys are all set for lessons. 11-6 will be on, actually it should be on tonight, I guess, that video. And you'll have every single video for all the sections. Include a little bit, those are the videos that we recorded in class together. And that's it. So just study this, guys. Any questions you guys have, please make a note to yourself that you must watch 10-4. Okay? You absolutely must watch 10-4, or else the exam is going to be much harder if you don't do 10-4. That is essential. Okay? All right. Bye, guys. Okay? You guys have a great day. See you, David. Yeah. Hey, how was your competitions?
It was good. In my books, we got to the grand final, but we couldn't hold on.
Oh, really?
Yeah, those guys are crazy. Like,
because they do it like year round, or what?
Like we do it year round, but like for lightweight racing, you have to say 150 or below.
All of them are.
All of those guys, they do this crazy thing where they'll beef up to like 170, and they'll get really muscular, and then like a week before the race, they'll cut, and so they're just a lot bigger than us. So
what? That doesn't even sound ethical.
yeah,
because it's not skill anymore. It's just size.
It's just brute strength. So like we don't want to do that, or like that sucks to do that. Yeah, but they're really competitive. So like they're gonna win
every little inch, huh? Yeah, to win.
Like, it's ridiculous how they do that. I don't know why they would, but
I'm learning a lot about that in MMA. Seems like those fighters would do anything to get an edge.
Yeah.
And it's just like, when you really think about it, it's not the most skill that necessarily wins. I will say this: it's the most quote unquote determined. Yeah. Meaning you will find any way you can to win.
Like the reason that like my votes were able to get into the grand final is because we have better technique than most of them.
And I think that's all that should suffice. It's just who's more technically skilled or sound. That's it. That's all it should be. But be proud then, because everyone can do brute strength, but it takes very few that can get the technique right. Yeah. Like how you toss a football, Obaid.
Yeah, no, I suck at that.
It is a work of beauty when you watch Obaid play football. Yeah. So he's got finesse and technique. All right, so bye guys. Have a good one. All right, we'll stop.